Hello, this is Geometry 7.3, proving a quadrilateral is a parallelogram. I'm going to try to make a connection or an analogy to parallel lines. If you remember the properties of parallel lines, for example, if you have two lines that are parallel and they're intersected by a transversal, then alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, and then consecutive interior angles are supplementary. But then the converses of each of those statements were used to prove that the lines were parallel. Kind of the same things here. Like we just went over in 7.2, the different properties of a the different properties of a parallelogram. Okay, now we'll try to use the properties of a parallelogram to prove that a quadrilateral is a parallelogram. For example, one way that you can prove that a quadrilateral is a parallelogram is by the definition of a parallelogram. If both pairs of opposite sides are parallel, then it's definitely a parallelogram. And then there's theorems as well that we could use to prove that a quadrilateral is a parallelogram. So if you remember the parallelogram opposite sides theorem, it states if the quadrilateral is a parallelogram, then the opposite sides are congruent. The converse of that is if a quadrilateral's opposite sides are congruent, then the quadrilateral is a parallelogram. If I have quadrilateral ABCD, I know that the opposite sides are congruent, then that quadrilateral has to be a parallelogram. That's one way you can show or prove that a quadrilateral is a parallelogram. So I have written down the parallelogram opposite sides converse. Going back to the parallelogram opposite sides theorem, it states if the quadrilateral is a parallelogram, then opposite angles are congruent. So the converse of that is if a quadrilateral has two pairs of opposite angles congruent, like I'm showing here, then the quadrilateral is a parallelogram. There we have the parallelogram opposite angles converse written out in words. The next theorem is a little bit different than what we've talked about as far as theorems in 7.2. It kind of stands on its own. It's theorem 7.9, or the opposite sides parallel and congruent theorem. So theorem 7.9 is actually not the converse of one of the theorems that we covered in 7.2, but here's what the opposite sides parallel and congruent theorem states. If you have a quadrilateral, if exactly one pair of sides are both parallel, so I'm going to make this top and bottom side parallel, and congruent, then this quadrilateral has to be a parallelogram. So exactly one pair of opposite sides have to be both parallel and congruent. Be careful. Okay, some people think if I have a quadrilateral like this, if I have a pair of opposite sides that are parallel and the other pair of opposite sides are congruent, then people think that this has to be a parallelogram. It doesn't have to be. I mean, in this instance, it looks like it's a parallelogram, but I could have something like this. Here's a pair of sides that are parallel. Here's a pair of opposite sides that are congruent. This is not a parallelogram. It's a trapezoid, if I actually enclosed it. But the same pair of sides have to be both parallel and congruent for that to be a parallelogram. And for the last theorem of 7.3, or the last way that you could use to prove that a quadrilateral is a parallelogram diagonals converse. Before I go over this, you might need to refer back to your notes for the parallelogram diagonals theorem to be able to write the converse. But see if you can figure out what the converse is before we go over it together. Here's the parallelogram diagonals converse written out. And then to go over a specific example. If you have a quadrilateral, and each of the diagonals bisect each other, like I'm showing here using my tick marks, then this quadrilateral is a parallelogram. As a real quick review, here's all the different ways that you could use to show that a quadrilateral is a parallelogram. All the 5 ways that we just covered, including the definition of a parallelogram. So right here, just kind of a nice handy little table to show the different ways that a quadrilateral can be a parallelogram.